Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilman bin Shoaib. Today I'm going to present for LA242 about transistor application. The application that I choose is switch. Okay, what is switch? Switch is used for connecting or disconnecting the circuit with other electrical devices such as LED. Okay, the devices will be stated as turned on or turned off based on the condition of the switch. The two condition of the switch, which is will be open switch and closed switch. From the diagram itself, this is the symbol, electrical symbol for switch. For the open switch, will be disconnecting the circuit, and then the devices will be turned off. For the bottom one, the devices is connecting, and then it will be turned on. Okay, as you can see, if a person press the switch button, therefore the circuit will be connected, and then the light bulb will be turned on. Yeah. How a transistor act as a switch? From this, transistor using its saturated or cut off state to act as a switch. What is saturated or cut off state? It will be explained more detail after this, but you need to know that saturated mean the transistor will be turned on, while cut off state will be mean that transistor will be turned off. Okay, for operating regions, this is what we have learned in the LA1, which is the left shaded area. It calls the saturation region, while the bottom one is cut off region. While the cutoff region is at the bottom one because the IC equals to 0, as we mentioned earlier, the transistor will be 0, and then the saturation region is on saturated because the current is flowed through the transistor. Okay, for cutoff region, it is happen when no input base current is flows, and then no output collector current will be produced. Why this is happen? Because from what we learned from the formula, IC equals to beta multiplied with IB. If the IB equals to 0, therefore the IC also will be 0. And then next one, the collector emitter voltage will be maximum value. This is because if the IC is 0, therefore no current is flowed through the 1 kilo ohm, and then therefore there will be no voltage drop happen. So VCA will be in the maximum value, which is from the diagram itself is 3 volt. Here in the transistor itself, the depletion layer will be formed. Therefore, no currents can flow through transistor, and the transistor is stated as 2 fully off. Okay, this is the characteristic. So I will be reading it briefly. The input and base are grounded 0 volt. As we mentioned, the base current will be 0, therefore the input and base are grounded. The second one is base emitter voltage, VBE, will be less than 0.7 volt. And then the third one, base emitter junction is reverse bias, base collector junction is reverse bias. And then next one, transistor is fully off, which is we call cut off region state. And then no collector current flows, and then V out equals to VCE equals to VCC equals to 1. And then lastly, the transistor operate as an open switch. That's all for cut-off region. Now we move to saturation region, which is the transistor will be turned on. So the input base current will be maximum. Then the output collector current will be maximum also, because as I mentioned earlier, IC equals to beta multiplied with IB. Therefore, the output collector current also will be in maximum value. Then the third one is collector emitter voltage BCE is in the minimum value because if the IC is flows through the 1 kilo ohm, therefore there will be a voltage drop happen, and then the VCE value will be in the minimum value also. And then the depletion layer in the transistor will also be minimized, and then the current can flow through the transistor. So the transistor switch to fully on. For the saturation region characteristic, so will be this is only the inverse of the cutoff region characteristic. So the input and base are connected to VCC. Base emitter voltage BBE will be equals to 0.7 volt or above 0.7 volt. Base emitter junction is forward bias. Base collector junction is forward bias. And then transistor is fully on. And then collector current flows will be maximum value, and then VCE will be equals to 0 if the transistor produce ideal saturation, and then V out equals to VCE equals to 0, and then lastly transistor will operate as a closed switch. Okay, the transistor as a switch have a total of 5 application. First one is LED, as we saw earlier, and then the second one, transistor can connect with relay control circuit. And then third one, it can drive DC motor. Okay, next, it can also connect with LDR and light bulb. And lastly, it can also connect with thermistor. Okay, conclusion that we can get from this application. A transistor is used as a switch to provide an efficient way to control lamps and electronic devices. The transistor must be either fully off or fully on. The fully on state, known as saturation, allows current to flow through the transistor, and then the fully off state, known as cut off, blocks the current flow. Lastly, the transistor operates by using a small base current to control a larger control collector load current. Okay, that's all from me. Now for the Q&A session. Okay, that's all from me. Thank you.